Okay, today we're going to learn about standard deviation to measure how spread out your data is. So, like when you have data, the middle of the data might be the mean or the median here. Um, but how spread out the data is to the right or left, or bigger or smaller than that, that's a measure of standard deviation. It's one measure of that. Sometimes we call it the typical deviation from the mean. So we find, like, if the mean is in the middle here, and there's some data value out here, what's the difference or the deviation from the mean in either direction? It could be below or it could be above. What's that typical deviation kind of distance there from the mean? So let's use an actual data set here and try to find this. So let me start with this data set. Let me show you add a calculator page here. So to find the mean of these five numbers over here, XC is the name of the list. So 6.9 plus 8.7 plus 7.6 plus 4.8 plus 9 divided by 5 is going to give us the mean. So the mean is 7.4. So the mean equals 7.4. So like if you think about 7.4, this one is below the mean minus what, 0.5? 7.4, so that's like 1.3 above the mean. This one is, I guess, 0.2 above the mean. 4.8, wow, that would be like 2.6 below the mean, about. And 9 would be, I guess, 1.6 above the mean. So you see lots of different kind of variation. You don't have to actually do this every time. I'll show you a short way to do this, but I want you to understand these formulas. These are kind of complicated formulas to use. And so we're going to kind of use the calculator to derive each one of these. So the mean is 7.4. That's what X bar is. So X with a little bar above it is called the mean of the data. And so X is each one of these. Each one of these guys, or sorry, each one of these guys are X. In this setting, you're going to square those. This means to sum them up, this little epsilon here, and then divide by the number of terms. That'll give you the variance. Okay, so let's actually derive this for this particular function this first time. Let's actually hit the home key, go to your list and spreadsheet page, and call this list at the very top, call it XC, and put in the different data values there, 6.9, 8.7, 7.6, 4.8, and 9. Whoops. Okay, so it says to take each of the data values and subtract the mean of those data values. So I'm going to write it this way. So this is the formula bar. If you put an equal sign right there and then type in XC, which is the name of this column of data, minus, and I just type in mean of parentheses XC. So we're going to take each one of those data values minus the 7.4. And I get, actually, do you see these values right here? I get those same values if I did them all right. I think I did. I get the difference. So that's what this right there is, the difference between each data value and the mean. Then we're supposed to square that. So I'm going to call this one DIFF for difference. I'm going to call this one DIFF SQ underscore X SQ for difference squared. So for this one, I hit the equal sign here. Then I'm going to type in DIFF and then square it. And so I took each of these data values, like 0.5 times 0.5, or negative 0.5 times negative 0.5 is 0.25, etc. We squared each of those values. That's what this squared does right there. This symbol right here is the sum. So we're going to add those together. So I'm going to go back to my calculator page, not a scratch pad, but a calculator page. The scratch pad does not talk to the previous document here. So I really do need a calculator page, not a scratch pad. So I'm going to put the sum. So I'm going to type the word sum of diff SQ, I think it was called. See how it gets dark? That means it's a variable. And the sum of that is 11.3. In the formula, you divide by n. So I'm going to divide by 5. and I get 2.26 is my variance. To get standard deviation, you take the square root of that. So square root of 2.26 is 1.5033. So I think for this problem, 1.5033 is our standard deviation. We use Greek letters for some of these symbols. So again, x bar is the mean, and this symbol, this lowercase sigma, is standard deviation. So now let's do the same problem a much easier way. You won't have to do this by hand every time, by the way. I just want you to understand the concept of what's happening here. The reason we squared those values, by the way, was to get them all positive. So those are all positive differences. We summed them up and divided by how many there were, and square rooted it to get rid of that because we had to square them. So it all kind of works out. It's kind of a strange way to measure it, but it's saying on average or typically all these data values are about 1.5 from the mean on average or typically is what that means. So the typical spread is 1.5 for that particular data set. So let's do this the easy way. So first you have to put the data into, let me go back to that page here. So we're on page 1.2. So you have to have this data in there. So you have to have XC. You have to type in your data. It is typed in, so we're okay there. I usually go to a calculator page to do this. So I hit the menu key and I go to statistics, stat calculations, and the first choice is one variable stats. And so you say, okay, type in the name of the list. You can either type XC or you can actually hit the variable key if you want, I think, or no, you can actually click here, I guess, and choose XC from the list. So XC is the name of our data column. Say OK, and it gives us all this information. Like I think we've used this before with the 5-number summary, right? It's got the minimum, maximum, Q1, Q3, etc. But if I mouse up one click, it also has, do you see this right here? 1.5033 is the standard deviation of X. And so if you know that symbol means standard deviation, oh, I got it right there. I did all those calculations for me, which is very nice actually. Okay, so that's the way to get it the easy way. So let's try that again to make sure you're understanding. So we're going to use one variable stats here. Find the standard deviation of the data set. So hurricane strikes since 1851 is the name of this data set. I'll scroll down, I can't see it all right now. We'll get that in just a minute. Okay, so what I like to do is I like to hit the dock key here and insert a new problem. And what that does is now when I go to list and spreadsheet, it's on page 2.1. None of my old variables carry over at all. I kind of like doing that. Put your cursor up at the top, decade, strikes, and type in some of your data, 1, 19, 2, 15, 3, 20, 4, 2, 5, whoops, 5, 21, 6, 18, 7, 1, 8, 13, and let me see, there's a couple more data set pieces here. So 9, 19, and 10, 24. Okay, so I have all my data in. Make sure you do this. If you type in 24 and don't press enter, it doesn't know you typed it in. So make sure you press enter or cursor out of that last cell. Usually I try to go to the right, one of those cells, and you're fine. I like to go back to my calculator page. So I'm going to go back there. Oh, wait, no, I'm in problem 2. I need a calculator page in problem 2. So I'm going to hit the home key and go to the calculator page. So now page 2.2 is a calculator page. It talks to page 2.1 because it's in the same problem. Okay, so now I'm going to do my. Okay, sorry. So, whoops. Okay, so we've got all the data typed in, and we're going to at this point, add a calculator page. So we're right here, we've typed in all the data, hit the home key, add a calculator page, and hit the menu key, and we're going to go to statistics, number 6, one variable stats, and one list, and we're going to call the name of the list strikes. So we want the average number of strikes, we want the how spread out the strikes are, etc. So the average value, let's see, X bar is 19.2. So we have 19.2 X bar is equal to 19.2. And then the standard deviation is that, looking for that little symbol right there, the standard deviation is 3.09. So standard deviation is 3.09. I'm just gonna, for ease, I'm gonna put 3.1 there. Just kind of round it off. So they might take a question like this and kind of, this is what they like to do sometimes in stats. So this kind of a thing here. So let me kind of put, so the middle of this data is 19.2, right? So we have 19.2. If I go one standard deviation to the right, so I'm going one standard deviation to the right, I put a line right there. So I'm going to add 3.1. So 3.1 plus 19.2, that's like, I think 22.3. If I go one standard deviation to the left, so that subtract 3.1, that would be like 16.1 there. And so let's keep going. So let's go 2 standard deviations to the right. That would be plus another 3.1, so 25.4. And then subtract 3.1, so I'm going to go minus 2 standard deviations to the left. So that would be minus 3.1 would be 13. And we go one more. This will be plus 3 standard deviations. And that's 3.1, so that'd be 28.5. And minus 3 standard deviations in this direction. So that would be like, I guess 9.9, somewhere on there. So if you look at the actual data, I'm just going to kind of plot some of these points just so you can see a visual of what we're doing here. So I'm going to go through each one. So 19 is somewhere around here. 15 is somewhere around here. 20 is somewhere around here. 22 is, I'm not sure, right around there. 21 is somewhere around here. 18 is somewhere in this vicinity. 21, somewhere around here. I'm not sure exactly. 18, I guess I could have put that above that one. 18 is, again, somewhere around here. 21, again, somewhere right in that neighborhood. 13 is right around here. 19 and 24. So 19 is somewhere around here, and 24 is somewhere in this neighborhood. So you can see the data strikes. If you kind of like follow these lines up, like within one standard deviation. So like from here to here. So that's one standard deviation above or below the line. Most of the data strikes, the vast majority of them were within one standard deviation. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of the strikes were within one standard deviation there, it looks like, or something like that. Did I put too many strikes on here? I think I did. There should only be a couple 18s. I think I had a couple of, let me redo those for a second here. So 19 was that one, 15 is this one, 20. Sorry, when I get this about right here, so I'm working with the correct data. 22 is right about there. 21, we're going to call it that one. 13 is that one. 19 is that one. And 24. I don't know if I have did I miss one? So 1, 2, 3, 4, 5, 6, 7, 8. I missed two of them. 18 and 21, I think I didn't do. So 18, one of those is 18, and then one of the 21s is somewhere around here. Okay, so I did have a couple of extra points there. I was trying to figure out where those were. That one should be there, and that one should be there. Okay, now I have the data right. Sorry about that. I'm just trying to like demonstrate for you a picture of this. So it looks like 1, 2, 3, 4, 5, 6, 7. 7 of the 10, hurricane strikes were within 1 standard deviation of the mean. So typically, you're getting around 19, hurricane strikes in a decade. And 7 of the 10, the 100-year period, 7 of those 100-year decades, seven of those decades were within 1 standard deviation. Now, if we go within 2 standard deviations, so now I'm going 2 standard deviations to the right and 2 to the left, right about there, like we're right about on that line. All 10 were basically within 2 standard deviations. There were none that were past 2 standard deviations, and that's very typical of data. Data tends to be scrunched in along maybe 1 standard deviation here to the right. In fact, typically, this is what we use. Is called the normal model. We might get into this maybe next week a little bit with the normal model, but the mean here is in the middle of the data, and a lot of the data is usually about 68% of the data is scrunched in here. That was interesting. Right about 70% of the data was scrunched here in the middle. And that's very typical of this. Usually about 95% of the data is within 2 standard deviations. Almost all the data is within 3 standard deviations. Every once in a while you get an outlier that's so far out there. But if it's more than 2 standard deviations away from the mean, it's getting really unusual. And so we'll talk more about this later on, but I think they'll have some precursor questions like how many, they might say, for this data, how many data pieces were more than 1 standard deviation away from the mean, where there were 1, 2, 3 data pieces that were more than 1 standard deviation away from the mean. So they might ask you questions like that about the data. So you might have to kind of like, parcel it off. And again, this is 1 standard deviation. This is 2 standard deviations, the mean. So 1 standard deviation in each direction. You're adding and subtracting that standard deviation value there.